Okay, so for this one here, we've got a train moving away from us. Okay, so we know it's retreating, which means we're going to add or subtract the speed of the source. Add. Okay. We know the frequency of its whistle is determined to be 475 hertz. If we're determining it, that means we're hearing it. So that's which F? F or FO? F, right. Okay, so we know that F is 475 hertz, and then later on they tell us the actual frequency of the whistle, which we know is FO, is 500 hertz. Now, even if the wording of that was bad, I know the train's moving away. Should I be able to tell just from that which one's which? Right? I should, because if it's moving away, the one I would hear would be the lower of the two. Okay, so even if the wording's bad, if they give you both, you should be able to tell which one's which. Okay, we know the speed of sound is 350 meters per second, and we're looking for the speed of the train, which is the source of the waves. Okay, so we're going to have F equals FO, and that's going to be multiplied by V over V plus Vs. All right, so I'm looking for Vs. What should I move first? FO. All right, whoops. Not that one, because that's F. Thanks. Nobody said anything. Okay, all right, so we divide both sides by FO, so now that's gone. So now we have F over FO equals V over V plus Vs. All right, what do I need to do now? I need to flip it, right? So I'm going to go FO over F equals V plus Vs over V. Okay, now what do? Multiply both sides by V, and then subtract the other V. So what I'll be left with is this. The speed of the train equals FOV over F minus V. So that'll be 500 times 350 divided by 475 minus 350. All right, 18.4 meters per second. Okay, everybody all right with that one? Okay, now I'm going to go back because we didn't do number 2 yesterday. Okay, I want you guys to try number 2. Okay, airplane is approaching you. Okay, 360 kilometers per hour, which I'll save you some time. That's 100 meters per second. Because we divide by 3.6, so I saved you so much time by doing that one for you. Okay, so we're going to measure the pitch of its approaching engines to be 512 hertz. What must be the actual frequency of the sound, okay, of the engines? All good?
Yeah.
Okay, perfect, thanks. All right, give you a few minutes on that one, guys, and then we'll go through it together. Okay, so for question number 2, okay, we know the speed of the source, 100 meters per second. Okay, we know the pitch of the approaching engines, and it's measured, so that's the one we hear. That's F. Okay, is 512 hertz. Okay, and we're looking for the actual frequency, FO, and we know that the speed of sound is 345 meters per second. All right, so that's what we've got. We know the formula is F equals FO times V over V minus or plus? Minus, because it's approaching. All right, and I want to find FO, so I'm just going to divide the whole bracket over. Okay, and plug in my numbers and solve. So I'll have 512 divided by 345 over over 245. do it. Okay, that's going to equal FO. So when we punch in those numbers, we should get 364 hertz, which fits. That frequency is much lower than the one we hear, and the one we hear should be higher with the approaching. Okay. Are you good with that one? All right, so the only real trick here is making sure to interpret the question correctly, okay, and put in minus or plus. Okay, after that, it's just algebra. Okay. All right, so on that note, I would like you guys to do a couple of ones out of the workbook here. Come on. Come on. Okay, so I would like you guys to try those ones there, 1 to 11. Okay, just Doppler effect problems. I believe there's none in there with a moving observer, so I think you're good to go on those. Okay. Okay, so for number 2, okay, so standing at the railway crossing in the way of the train. So not smart, train approaching, okay. Train is approaching at 100 kilometers per hour. So I've got to convert that to meters per second. It's going to be 27.7? Yeah. Meters per second. Okay, sounding its whistle at 400 hertz. So that's the actual frequency. Okay, the air temperature is 20 degrees. That's going to help me to get V, right? So that's going to be 332 plus 0.6 times 20 degrees, okay, and so that'll give us 344, something like that. 344. And we are looking for the frequency he will hear as it approaches, and then the frequency of it as it leaves. Okay.
So just asking.
Yeah, it's just asking for both. So it's just asking you to do it both ways. Yeah?
Yeah, I didn't, he lies cowering in the ditch didn't make sense to me.
Yeah, so like he jumps out of the way just in time and then the train goes by and he hears a different frequency. So yeah, it's one of those times, like all the other times I tell jokes and they flop. Just like that. Okay, does that make sense then?
Yeah.
Any other ones that we need to talk about so far? Okay, so it doesn't matter what the frequencies are, it just matters how much different they are from each other. Yeah. So as long as I pick 2 numbers that are 3% different, I'm good. So I'm gonna pick F to be 103, and I'm gonna pick FO to be 100. Those are 3% different from each other. Okay, and then I can say that the speed of sound, okay, is 340 and look for the speed of the source. Okay, I could pick 200 and 206 or 300 and 309, any 2 numbers that are 3% different. That's just the easiest one to use because it's obviously 3%.
Okay.
Right? Okay, and then so I would have F equals FO and V over V minus Vs because it would be approaching. Okay. And then I would simply manipulate for Vs, so that's going to be FOV over F minus V, okay, is going to equal negative Vs. And then when I plug in my numbers, okay, I'll have 100 times 340 divided by 103 minus 340. Okay, so it's got to be moving at 9.9 meters per second.
Okay, thank you.
Yep. Any other ones, guys? Anybody done all of them?